Before we use Python to calculate correlation between variables, let's see how we can test the statistical significance of the correlation coefficient. Significance tests allow us to assess whether the apparent relationship between the random variable are the result of chance. If we decide that the relationships do not result from chance, we will be inclined to use this information in predictions because a good prediction of one variable will help us predict the other variable. Before we can perform the significance test, we must know some details about the distribution of underlying variables. For purposes of simplicity, we will assume that both of the variables are normally distributed. Now we are ready to state our hypotheses as follows. The null hypothesis, or h sub 0, that the correlation between the two populations is 0, versus the alternative hypothesis, or h sub a, that the correlation between the two populations is different from 0. The alternative hypothesis is a test that the correlation is not equal to 0, therefore a two-tailed test is appropriate. As long as the two variables are distributed normally, we can test to determine whether the null hypothesis should be rejected using the sample correlation, or R. The test statistic is a t-test with n-2 degrees of freedom and is calculated as the sample correlation, or R, times the square root of n-2 divided by the square root of 1 minus r squared. Let's look at an example. Recall in the last video, we calculated 0.9083 as the sample correlation between the long-term money growth and the long-term inflation in 6 industrialized countries between 1980 and 2012. That estimated correlation seems high, but is it statistically different from 0? To test that, let's first state our hypotheses. Null hypothesis that the correlation between the two populations is equal to 0, versus the alternate hypothesis that the correlation between the two populations is not equal to 0. Recall that this sample has 6 observations. We can compute the statistic for testing the null hypothesis as follows. T with n-2, or 4 degrees of freedom, is equal to 0.9083 times the square root of n-2 divided by the square root of 1 minus the square of 0.9083, which gives us a t-value of 4.343. To find the rejection points, we look at the table of critical values of the t-distribution for a two-tailed test with n-2, or 4 degrees of freedom, and at the 0.05 level of significance. We find the rejection regions of greater than 2.776 or less than negative 2.776. Since the calculated value of 4.343 is greater than the rejection point of 2.776, we reject the null hypothesis that the population correlation is equal to 0. The rejection of null hypothesis of no correlation demonstrates the strong relationship between long-term money supply growth and long-term inflation in these 6 countries. Now that we have covered all of the background information regarding correlation, in the next video we will learn how to calculate correlation using Python.